In this video, I will be going over a few practice problems on interval of convergence, radius of convergence, that stuff for power series. So I would recommend you follow along and try the problems first before coming to see, or I guess pausing the video first to try the problem first on your own, and then unpausing it to see my solution to help you out if you got stuck, and of course to check your answer as well. All right, there's not too many in this problem set. There's some important ones to go over with different types of cases that you might see. Okay, number one, part A, find the radius of convergence of this series, summation as n goes from 0 to infinity, -1 to the n, x to 2n over n factorial. So go ahead and try this first on your own. Pause the video, try the problem first, and then pause it and see how I approached it. Okay, so this is what I did. So to find the radius of convergence, we typically use the ratio test. So you got to be careful with your parentheses here, though. Wherever there's an n plus 1, wherever there's an n, we're going to replace it with an n plus 1. Because the ratio test says it's a sub n plus 1 divided by a sub n. Okay, so this is why I said be careful with parentheses. It's 2 times in parentheses n plus 1. Okay, it's not 2n plus 1. It's 2 times parentheses n plus 1. Okay, so this is what happens, and then I'll go through the algebra this time. So distribute this 2 to both those, and then this n plus 1 factorial we can rewrite as n plus 1 times n factorial. These n factorials cancel, and then these two can simplify. We subtract the powers by properties of exponents, and we get x squared left. So we'll have the x squared over n plus 1. Okay, x squared, it doesn't depend on n, so it's like a constant. We can move it out in front. Technically, there should be absolute value. So it should be absolute value of x squared. But since we're squaring something, it's always going to be positive. So we could drop the absolute value sign. All right. Now, what's this limit as n goes to infinity? It's 0. So 0 times x squared is 0. So what's the radius of convergence here? Is it 0? No, that's not the case. Let's recall what the ratio test says, first of all. If this limit is less than 1, the series is convergent, or absolutely convergent, to be more precise. In this case, the limit is 0 all the time, independent of x. So what does that mean? This means this power series converges for all values of x. Okay, if you've seen other problems, this limit might have x inside it. Like, for example, let's take the example. If this is not 0, like 1, then this limit will be x squared. So we would have the x squared to be less than 1 because the ratio test says it's convergent if that limit is less than 1. This is always less than 1. 0 is always less than 1. I hope you would agree with that. So it doesn't matter what this value of x is. No matter what x value we choose, this series will always converge. Therefore, the radius of convergence is infinite. You got to get this right. This is a special, not really a special case, but a not as typical case. Okay, typical people, students, might be used to taking this, setting it less than 1, and then solving for the absolute value. So here, since there's no x over here, they might just be like, oh, this is the radius of convergence, 0. No, that's not the case, though. It's infinite. Okay, so we got to not just blindly follow procedures, we got to understand what we're doing. This is what I always emphasize to my students. Okay, part B. How about this radius of convergence? Summation as n goes from 0 to infinity, n factorial times x plus 3 to the n, all over n squared. So go ahead and try this on your own. We use the ratio test again. Limit as n goes to infinity, a sub n plus 1 divided by a sub n. Okay. I'll go through the algebra again. N plus 1 factorial is n plus 1 times n factorial. So that n factorial, that would result, and this n factorial down here cancel. X plus 3 to the n plus 1 power divided by x plus 1 to the n, x plus 3 to the n, sorry. I'm trying to go a little faster, but I'm messing up my words. We can use properties of exponents, subtract the powers, so we're left with x plus 3 to the first power. Similarly, actually these two you can't simplify. Okay, so this is what happens over here after we clean it up a little bit. All right, now what does it depend on n that we can pull out? This x plus 3 does not. We pull it out, but we got to keep the absolute value. Okay, unlike in the other one, since it was always positive, we could drop the absolute value. But this, it could be negative. Okay, now what's left on the inside is just n squared divided by n plus 1 because, well, that's n plus 1 divided by n plus 1 squared. I guess I'm missing that over here. They would cancel one power on the bottom. Okay, so that's why we're left n squared over n plus 1. Now, what happens if we take the limit as n goes to infinity of this? Well, the n squared would dominate, right? So it would approach infinity. So what's the radius of convergence here? Is it infinite? No, that's not the case. So that we have to be careful here. So this is another kind of not really a trick question, but if this comes up on the exam, and again, if you're just blindly following procedure, you might miss this. Okay, so let's again recall what the ratio test says. If this limit is greater than 1, the series diverges. So does this power series never converge then? If the ratio test says that it does not converge? No, that's not the case either. What happens when x is -3? It'll be 0 to the n power, which is just 0, right? 0 times who cares is 0. So we're actually summing up an infinite amount of zeros. So wouldn't you agree that the power series converges at x is -3? Right? So what's going on? We got to remember the definition of a power series. It must converge at its center. The center of this power series is x to -3. And so that's what I said at this bullet point. Recall a power series must converge at least at one point, its center. Okay? And yeah, as I just said, the center of this power series is x equals -3. As I just demonstrated, if we plug in x is -3, we'll be getting 0. So we're summing up an infinite amount of zeros. For sure, it's going to converge. Therefore, what's the radius of convergence of this guy? The radius is actually 0 because it converges at its center and nowhere else. So it doesn't branch out like a radius, it branches outward, right? It doesn't branch out at all from its center. So we say the radius of convergence is 0. Versus for this one, the center of this power series is 0, right? And it converges everywhere. So 0 plus a radius of infinite in both directions. That's why the radius of convergence is infinite. Hopefully this is a little more clear now if you didn't understand what the radius of convergence is. A power series must always converge at its center. Okay, plus or minus a radius. The radius could be 0, like it is in this case, meaning it only converges at the center. The radius could be infinite as well, meaning it converges for all values of x. Okay, these are two more special cases that, again, if you just blindly follow the procedure, you might miss the concept. All right, number 2. This series converges on what interval? Go ahead and try this on your own first. So this is asking about interval of convergence. So we go through the motions. We first use the ratio test to get the radius of convergence. Limit as n goes to infinity, absolute value of a sub n plus 1 divided by a sub n. This time I'm going to skip through the algebra. You can definitely pause the video to check it out yourself. Okay, we take the limit. It's absolute value of x over 4. So the ratio test says this guy has to be less than 1 for it to converge. So we set this guy less than 1. If we solve for absolute value of x, that means absolute value of x is less than 4. The radius of convergence, therefore, is 4. So going back to the concept of radius of convergence, this power series converges at its center, 0 plus or minus a radius of 4. So 4 and -4. Okay, and that's how we actually start solving for the interval of convergence. We solve this inequality. X is between -4 and 4, as I just explained. It must converge at its center of 0 plus or minus the radius of 4. So 0 plus 4, that's 4. 0 minus 4, that's -4. Okay. At these two endpoints, recall that the ratio test says that if the limit is equal to 1, the test is inconclusive. That happens at these endpoints. That means we got to check ourselves if the series converges or not at these two endpoints. So we plug in x is -4 into the original series over here, x to -4, okay? We would get n squared times -4 to the n over n to the fourth, which if we simplify, we would get -1 to the n power n squared. This is clearly a series that diverges by the test for divergence. The limit is not equal to 0. Okay? So we don't include x is -4 inside the interval of convergence. Similarly, we check the other endpoint, x is equal to 4. This is what we would get, and it simplifies to n squared. Again, this is clearly divergence, so we don't include this endpoint either. So therefore, the interval of convergence is -4 to 4, not inclusive of either of the endpoints. Or you can write it in interval notation as well, like this. Okay. Number 3, if f of x is this guy, find the interval of convergence of f prime of x. So go ahead and try this first on your own. So we probably want to get f prime. We can just differentiate. Okay, so we would get 1 plus x plus 1 plus x plus 1 squared plus dot 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 dot. Okay, we can rewrite it in summation notation as well. It's summation as n goes from 0 to infinity, x plus 1 to the n power. Now we want the interval convergence of this guy. This is our f prime. Okay, so we go through the motions. Ratio test first. Okay, and okay, let me go through the algebra here. I might get confused. So this is the setup for the ratio test. We divide. So we subtract the powers of exponents. So we just get x plus 1 to the first power, okay? What's the limit of this guy? Well, it doesn't depend on n, right? So it's like a constant. Or you can even write it like this. We can pull this out in front. It's like a constant. And limit as n goes to infinity of just 1, which is just 1, right? So this is the result of our limit. And we set it to be less than 1 for the ratio test. We start solving the inequality. So x is between -1 and 1. Oh, sorry, this should be x plus 1 is between -1 and 1. This line is right. Okay, so this x is between -2 and 0. Okay, again, hopefully you see the radius of convergence happening. The center of the power series is x equals -1. The radius of convergence, yeah, x and -1. The radius of convergence was, did I do this right? Yeah, sorry, the radius of convergence is 1. So -1 plus 1, that's 0. -1 minus 1, that's -2, -2. Okay, so hopefully I'm solidifying your understanding of radius of convergence. Okay. So now we have to check the two endpoints manually because the ratio test is inconclusive there. We plug in x is -2 into this guy, into our f prime that we're trying to find the interval convergence of. So we would get -1 to the n. This is clearly divergence. Okay. We plug in the other endpoint. This is 1 to n. This is clearly divergent as well. So the interval of convergence again does not include the endpoints here. So it's just -2 less than x less than 0. Okay. And that's it for this problem set. I thought there was 4, but there's only 3. So hopefully you from the sets, if you problem set, if you didn't grasp the concept of radius and interval of convergence before, hopefully it's more clear now, especially from solving those first few problems. All right. Please give this video a like if this has helped you in any way. And also, it'd be great if you can subscribe to the channel and you'll also get notified for more videos like this.